Did you have any questions over that section 4.2? Anything? We'll look at 4.3. We're going to be looking at derivatives of natural logarithmic functions. And if you notice there on page 343, you take the derivative of a natural log. It's 1 over x. And then on the next page, it's going to talk to you about the chain rule. So if you have a natural log and it's of a function, then you take the 1 over the function and then take the derivative of the function. So chain rule is going to apply. So we'll look at some problems on 349. Number 2. So if we take the derivative of this, then it's 1 over the argument there, 5x to the 7 plus, I don't have it up here. I can see it. Thanks. I pushed the little button once, but it didn't work. I can go through a whole lecture that way. Never bother me. Okay, so we do 1 over the argument. That's what the derivative of ln is. Then we have to do the derivative of the argument. And that's going to be then 10x plus 3. Remember to put that in parentheses, because that's just a derivative of polynomials. So, let's see. I don't know if there is a common factor. I mean, we could write this as 10x plus 3 over 5x to the 7 plus 3x. Now, if you could reduce that down, you'd want to, but there isn't anything that's going to. There's an x comes out of the denominator, but that would just leave you 5x to the. So that's the way you leave it. So 4. E squared ln 5. Remember, E is a number, so don't think of it as a variable that you have to do a derivative of. So if you do the first derivative, it's going to be E squared, and then it's 1 over that argument, 1 over 5x cubed times the derivative of the argument. So that's going to be 15x squared. So it's E squared times 15x squared over x cubed, and then this is going to just leave us x. Now you could go ahead and find out what the e squared 15 is going to be. That's going to take using a calculator. Let's see, when you do the derivative of 5x cubed dx, that 3 comes down and it makes 15, and then x squared. Did I do something? Oh, and then there's a 5. Oh, I see. There's a 5 here. So then this would be 3. Thanks. 3e squared over x. Okay. So you could get an approximation of that 3 times e squared. If you do 3 times second e squared, that's about 22.17. Correct. If you want to get, and that's an approximation. As far as I'm concerned, this is the preferred answer. I don't know if the book would do the 27 over. And I just, I don't know. See if I got it over here, maybe I can see it. Let's see my calculator results. That's still big enough that you can see it. Look at this. Okay, we had 4. So what I want to do, 6. F of x equals 4x ln x. Okay, we're going to have to do a chain rule, so it would be the derivative. It would be the derivative of the 4x, which would be 4 times ln x, plus the first term, the derivative of the second term. So what we have, this would go out, 4 ln x plus 4. Or, you know, you could, if you wanted to, this is the derivative. And if I'm looking for an answer, I'd take either one of those. Now that particular thing the rules of logs say this, that you can write this function as 2ln of x squared plus 3x. So if you just take the exponent out in front, that's just the rule of logs. It's still talking about function. We haven't done anything derivative-wise. Then if you do the first derivative, then it's 2 times 1 over the argument. And then it's times the derivative of the argument. And then put a bracket. So that's 2x to the first plus 3. So, 2 times 3. Now, you can see that if we try to do anything, if we tried to factor that or reduce that down in any way, we don't really get any place. The numerator is factored this way, and the denominator is prime factored. So there's nothing we can do. I mean, it's so in terms of what answer. I guess if you look it up in the book, I don't know which one of those two, I'd take either as an answer to the problem. Number 10, it's f of r equals 5 ln of 2r minus 1 to the 6th power. Now, I want you to note that that 6th power in this one is different than this. Do you see that? That's on the outside. And so what we're going to have to do is we're going to have to differentiate that as if this were inside here, where as a variable. That 6 is going to have to come out in front and reduce it by 1. Right. So we're going to have to do 30 ln of 2r minus 1 to the 5th power. Then we've got to do the derivative of what's inside there, and that's 1 over 2r minus 1. And then we have to do the derivative of the argument, which is 2. Does that make sense? You see how that power of 6 is different from this power of 2. This power of 2, then the rule of logs applies. But here, the rule of logs don't apply. If that square bracket wasn't there and that 6 was out front, you'd take the 6 out in front and have 30 ln of 2r, and that's what you'd be differentiating. Now, this, you bring the 2 over, we got 60. There's not going to be anything that's going to reduce, I believe. Now, that square bracket technically doesn't have, it has to be there, because this is a power of 5 over 2r minus 1. And that would be all you could do to simplify that. Makes sense? This is ln third root 7c plus 7. Now the first thing you want to do with that is take that radical and turn it into a fractional exponent. Now you see this thing is, that exponent is the same thing as that. So that means that that 1/3 is going to come out in front. This is still function. We're just using the law of logs. 1/3 ln of 7c plus 7. That's just the rule in logs, right? Now we're ready to differentiate it, because we got it written using the rule of logs. So then this is 1/3, and then it's 1 over the argument, and then the derivative of the argument. So now then, this is going to be 7 over 3 times 7c plus 7. And what we can do is we can factor a 7 out of that. We have a 7 in the numerator. 3 times 7 out of c plus 1. And then this will go here, so it's 1 over 3 times c plus 1. Or you could write it as 1 over 3c plus 3. Whichever way, let's see. I mean, once again, don't make any difference which way you do it. That would be, I guess. ln, we've got ln p squared. Okay, you start from the outside, doing the derivative. So this would be 1 over the argument. ln of v quantity squared. Then we do the derivative of the argument. So I'm just going to do it this way. I'm going to do it the derivative of the argument. Now that this is 1 over ln v quantity squared. So what you have to do with this is that q comes out in front times ln of v. Now that is just applying the definition of logarithms. I'll take that back. This has got to be 2 ln of v to the first power. So that's the derivative of that. Then what you do is you have to take the derivative of ln v, which is 1 over v, and then the derivative of v is 1. So that's what that would be. Understand this one right here is actually taking the 2 out in front, ln of v to the first power. So now then, this LNB reduces this to 1, and we have a 2 in the numerator over V LNB. I just could write it this way, 2 over V times LNB. And that would be try that hard one. 16 has got to be the hardest one of this group. F of S. LN6. 5 LN 2S plus 1. Now, what you want to do is think about it. This LN6, that's actually just a number. That's a constant. So you're not going to do anything derivative-wise with it. And what you want to do is get this thing in the denominator and numerator. So it's LN6 times 5. I'm not going to bring that 5 up. I'm going to leave it down. I'm going to bring this LN of 2. That S is going to look like a 5 sometimes. So. Now don't do this. Don't write this thing right here as ln of 2s plus 1 to the minus 1 power. That's not right. You see that? The whole thing is coming out. Because if you wrote it like this, then this would be a minus ln of 2s plus 1. Right? Because the 1 would come out in front as the rule of logs. That's not what happens. That whole thing is coming up. So essentially, this is what we got. We have a constant, that's a number, and with that constant number, and we're doing this. ln of 2s plus 1, and that's just the function. That's not the derivative, that's just the function. Now we're ready to take the derivative. So this ln 6 over 5, that's just a constant number. Now we're going to take the derivative, and the first thing you've got to do is do the square bracket. So we're going to go minus ln of 2s plus 1 to the minus 2. And then you have to do the derivative of what's inside. Well, that's 1 over the argument. And then the derivative of the argument is 2. Oh, by the way, this is not that number minus that. This is a product. Correct? So if we join all this together. I'm going to write this 2 out in front. This is 2 L and 6. And I'm going to bring this minus sign out in front here. Over 5. Then I'm going to put this thing right here in the denominator. So it's 1 over ln of qs plus 1, the quantity squared. And then this thing is in the denominator, 1 over qs plus 1. Let's try to accumulate this all together. In the numerator, when we put all this together, it's a negative q ln 6 all over ln qs plus 1. The whole quantity is squared times 2s plus 1. And that's a quantity. And that's f of s. Okay. I left it off. Should be down there. Thanks. Okay, that next one says the two problems are intended to give you practice reading and paying attention to the instructions that accompany the problems. So I'm going to look at 20. So it's g of x equals 8 ln of 4x. Now the first thing says find g of 1/4. So you're just going to put 1/4 in for x. So it's 8 ln of 4 times 1/4. Which is equal to 8 ln of 1, and the log of 1 is 0, right? What's the power that e has to be raised to get 1? So that's 0. So that's what that is. And the b part says g of e, round to the nearest whole number. I guess this one, they asked you to find the point on the graph. So the point on the graph is 1/4, comma, 0. The b says find g of e. So that's 8 ln of 4e. Now we can find that what that ln of 4e is. It's going to be a number. I'm just going to go 8 times ln of 4e. And I'll put to the first. 1909. Now then, it's the C part. So find G prime of E. So what I first want to do is do the G prime of X and then plug E into it. So I got this together. This G of X equals 8 ln of 4x. Right? Now G prime of X is 8, 1 over the argument, divided by the argument. So this goes out. And I have 8 over X. So G of prime E equals 8 over E. And then I can try to calculate that number out. Now it says use the results of your computations of G of E and G prime of E. Find the equation of line tangent to the curve at E, G of E. Okay. Now, remember the first derivative is actually slope, right? At that point. So that's m for that point. And then we have, back up here, we have this point right here, which is E 19, right? That's what this point is. And what they want is they want to have the equation of the tangent line. So we have a point and a slope, so we can find your straight line using point slope method. So what we do is it's y minus y1 equals m x minus x1, where x1, y1 is E19 approximately, and m equals 8 over E. Right? So then I go y minus 19 equals 8 over E x minus E. Now if I multiply this through, this is 8 over E times x minus 8 over E times E. That little dot is not supposed to be. Minus 8. So y equals 8 over E x plus 11. So there's your slope-intercept form of the line that's tangent to that curve at E at x equals E. So, any questions on that? Okay. Here they want to do implicit differentiation. We have 4x plus ln of x squared y to the fourth equals 10. So if we differentiate that, this is just going to be 4 plus. Differential there is 1 over the argument times the derivative of the argument. So that's going to be the derivative of the first times the second plus the first times the derivative of the second, which is 4y cubed y prime equals 0. Right. So 4 plus, and I got to run this thing through that so I can get it. So that's going to be 2x y to the fourth over x squared y to the fourth plus, this is x squared, I'll put the 4 out front, x squared y3 y prime over x squared y to the fourth equals 0. I'm going to try to get y prime by itself, but I'm going to reduce this thing down. Those go away, right? And this makes this a 1. On this one, these go away, and that makes that a 1. So if I move things around, I'm going to, but I have 4 plus 2 over x plus 4 y prime over y equals 0. So now I get my 4 and my 2 over x on the other side. So it's 4 prime over y equals 4 minus 4 minus 2 over x. Now I'm going to multiply both sides by y over 4. Y over 4 minus 4 minus 2 over x. And I'll distribute that through, so I have y minus y minus, I'll leave it. I'll go 2y over 4x minus y over 2x. Okay. So that should be my answer right there. X cubed y to the fourth minus ln of x cubed y equals 5. I want to differentiate that. So this is the chain rule. So this is going to be, I'm going to take the derivative of the first. So I'm going to go 9x squared y to the 4th. I'll put a bracket on this. Then it's plus derivative of the second. So that's going to be 4, that's 12. 4 out in front. So that's 12x cubed y to the 3rd minus, all right, the derivative of that is 1 over the argument, y, and then the derivative of the argument. Now that is a chain rule is going to apply, so that's 15 derivative of the first, because it's a second, plus, I'm going to put a bracket on here. No, I guess I got the bracket here. Plus the derivative of the second, so that's just 5x cubed y prime equals 0.
Can you have a white on the first one?
Oh yeah, right here. Okay. So then, I don't need the brackets, but I'm going to rewrite this. 9x squared y to the 4 plus 12x cubed y third y prime minus 15, I'm going to run that denominator 5x cubed y through there. X squared y equals 5x cubed y. And it's a minus 5x cubed y prime. 5x cubed y. Alright. So first three, nothing is done, but this one becomes 3. That becomes 1. And these go out. This cancels, that cancels. Okay. Let's do that. Now I'm going to go ahead and move these over to the other side. And this one. And then I'm going to leave this one on, oh, what the heck. I'm going to move this one over to the other side. I'll make it positive. Y. I'm going to back up row. Because I have a y prime here. I have a y prime here that I got to combine with this y prime. So I'm going to leave those two on the left and then move everything else over on the right. So I got 12x cubed y to the 3rd y prime minus y prime over y. And that equals, bring this one over first, plus 3 over x minus, I'm taking that one over, 9x squared y to the 4th. We're going to factor out the common y prime. I have 12x cubed y cubed minus 1 over y. what I want to do with this thing right here, I want to get it over a common denominator. So y prime, then I'm going to have 12x cubed y to the fourth minus 1 all over y. And on this side, I want to get it over common x. So that's a 3 minus 9x cubed y to the fourth over x. So I prime. And I'm going to invert and multiply. This is y over 12x cubed y to the fourth minus 1 times 3 minus 9x cubed y to the fourth over x. I don't think there's anything you can do with that. We could combine the x in there, but that's essentially it. I don't know what the book would write it as. If we distributed the y across, 3y minus 9x cubed y to the fifth. Distribute the x across, we got 12x to the fourth, y to the fourth, minus x. Pretty ugly answer.
Why do you keep changing
Oh, well, so I multiplied this x times here, and that this one becomes 4. And then I multiplied this y through here, that's why it became 3y, and then this became the fifth guy. Is that what you're asking?
hanging up a little bit? Or you change it from the x 12x to the third y to the fourth? Where did that come from? I was thinking it was
Well, I did a common denominator. I multiplied this thing by y over y, so I could write it with a common denominator. And I did the same thing here. I multiplied this by x over x. No, but then I didn't have to. But that's where that y came from there. Any other questions? Yeah. Is that okay? Okay. And then these next 25 through 29 says find that and interpret each derivative. So, 26. F of x equals ln of 5x plus 1 quantity squared. Now, that particular thing, using the laws of logarithms, that 2 comes out in front. Before you start doing the derivative. When you do the derivative, it's 2, and then the derivative of ln of 5x plus 1 is 1 over the argument, times the derivative of the argument, that's 5. So, first derivative equals 10 over 5x plus 1. And then f, first derivative, at 0. So what it says is 10 over 5 times 0 plus 1 equals 10. And so what's the meaning of that is when x goes from 0 to 1, f of x increases by 10. 10 units. First derivative is the margin. That's what they want to know. So we got f of x equals 3 ln of 4x minus 2 ln of 3x. Okay, so first derivative is 3 1 over the argument times the derivative of the argument minus 2 1 over the argument times the derivative of the argument. Okay. Over 4x. Oh, look, let's just cancel that. Cancel this. This was 3 over 3x. Yeah. 3 over x minus 2 over x. So first derivative of 6 is 3, 6 minus 2, 6, which is 1 half. That's it. No, but better not do it that way. I better do it 1/6. So what does that mean? As x goes from 6 to 7, f of x increases by 1/6. Here they're just saying, is the derivative as given there correct or not? So what you do is you take the derivative of the function of x cubed that's 1 over x cubed, 1 over the argument, times the derivative of the argument, 3x squared. So this is going to be 3 over x. And their question is, they said f prime of x equals 1 over x cubed. So, what is it? Incorrect, right? What they said it was not right. So this is incorrect. F of x equals ln 3x squared plus 5x minus 4. The first derivative is 1 over the argument and then it's times the derivative of the argument. So this is 6x plus 5. There isn't anything to do with that. 6x plus 5. Their claim is that derivative was 1 over 6x plus 5. That's not incorrect. That's incorrect. F of x equals 18 ln x. And so that's 18 times 1 over x. The derivative of the argument, which is 1, so 18 over x. That's what the derivative is. And they say f prime of x equals 18 over x. So that's correct, right? F of x. N x ln of 8. Now, you should analyze this thing. That ln of 8, you don't take a derivative of it, because that's a constant term. Really what you have is, you have 10 times ln of x. That's a constant term. And it's times x. That's what this function is. So then the first derivative is just 10 times ln of 8. First derivative of x. And their statement is that this is the first derivative is equal to 10. That's incorrect. f of x equals 12 ln 2. Now, those are just constants, so if you take the first derivative of that, it's got to equal 0, right? And they're saying f prime of x equals 0, so that's correct. We'll look at 44. It says radioactive decay. At the start of an observation, there are 100 grams of radioactive element present. The number of years T that must be passed before n grams remain is given by the natural logarithm equation given there. Find dt dn when n equals 20. So we have t equals 7, 4, 9.5 minus 6, 9, ln capital N. So dt dn. This is 0 minus 1639 times 1 over n. So what we could say is this is actually a function of n, is what this is. So first derivative, so negative 1639 over n. So then the first derivative, 20 equals 1639 over 20 minus. And that probably won't go evenly. Negative 8, almost 82, 81.9. No, it says the number of years T. There are 800 grams in radioactivity element present. So the decay over that 20 years is 8195. So the number of grams present is 100 minus 8195. Okay, what are we talking about? Zero, 10 grams. Says a senior editor of the Life Sciences at a textbook publishing company has determined that the equation there relates the expected number in thousands of copies of an introductory biology textbook sold in 1 year period to the number of X in thousands of complementary copies sent to professors throughout the country. Primary interpret the rate at which n changes as x changes when x equals 6. So, n of x equals 1.26 plus 2 ln 1.1 x up 3. There's 3 over here. So it's going to be 0, 1.2 times 1 over the argument times the derivative of the argument, 3x squared. That's it. Bracket. 3.6 x squared over 1.1 plus x cubed. And then they say x is 6 and 6. 3.6 times 6 squared 1.1 plus 6 cubed. Copies of anything. 1 year period. So this, if we plug that into the calculator, 3.6 times 6 squared. So it's 3.6 times 6 squared. Come on. Oh, that's squared out. Divided by bracket 1.1. Is that a plus or minus? Plus. Plus. That was 6 cubed, isn't it? So the third. Get it out of there. .59, not much. So when it goes from 6 to 7, it drops it by half of it. Look, thousands, right? Thousands. So it's that's quite a bit. 0.59 thousands. Okay. We go 6,000, 7,000 drops. $590. 590. Okay. So we'll do have a quiz on Tuesday, right? Tuesday. Next time we meet. we'll finish up 4-4, and that'll be what's on the test.
Will the choice be over just this stuff?
Yep. It'll probably, I might do 4-2 and 4-3, because that's what we did kind of in there. 4-2 and 4-3. Couple problems from each one.